Guten Tag, Mr. Ferrante here, and welcome to problem 1 of the Chapter 8 practice test. And anytime if I say pause during the video, that means you're supposed to pause the video and work on your own from there, because then you'll see I'll provide solutions after that point. But if you just watch me do these things, then it's not going to do you that much good. So make sure that you try yourself as much as you can, pause the video and do that, then let the video roll past. And I'll let you know when I think you should be doing that. Thanks. All right, so first up, pause the video and read the actual problem. All right, so we've got Martin throwing a softball, and it's gonna, when you throw things in the air, it makes a parabolic shape. In fact, if it wasn't for air resistance, then it'd be an exact parabola. You know, with air, it messes up the path of the parabola, but it's still pretty decent. If you watch a football being thrown from the side, it really does make this, parabolic arch. And that's the cool thing. Parabolas really are a real world phenomenon. All right, so we've got Martin throwing a softball. They give us an equation. It's right here. Y equals negative x squared plus 10x. Fine. The first set of directions says to make an xy table for values of x from 0 to 11. And those values are already filled in for us. They're right here. We already have values from 0 to 11. What we need to do is plug in the x values, compute the y value, and then plot those numbers on our graph below. So let's start doing that. Take our equation, y equals negative x squared plus 10x, and I'm going to do my scratch work down here. So we had y equals, now instead of x, replace x with parentheses. If you do this every time that you plug into an equation, you'll save yourself a lot of grief by not missing double negative signs. Just wherever you see x in the equation, replace it with empty parentheses. So I've taken, in our case, these x's right here, and I simply replace those with the parentheses down here. And now that I have parentheses there, I can go fill those in with all the numbers I've got in my table. And I'm much less likely to make mistakes this way. So I'm going to just do a few for you and let you do the rest. So let's start with 3, plug in 3 for x. Now I have to discuss what this first part really means. Remember, the order of operations is PEMDAS. PEMDAS. I'm going to assume that you know what these stand for. If it's versus parentheses, there's nothing inside these parentheses, so we're done with that. Exponents are next, which means you have to square the 3 before you multiply this negative to it. You can think of the negative on the outside as negative 1 is being multiplied to this stuff. And right here, exponents comes before multiplying. So you have to do 3 squared is 9. Then after you have 9, this negative 1 gets multiplied to that result. So this becomes negative. That's the first spot that students mess up when they're calculating the numbers for this problem. Then 10 times 3 is 30. So when x is 3, we've got y equals whatever negative 9 plus 30 is. That's the same as 30 minus 9, which would be 21. So when x is 3, the y value is 21. So go ahead and pause the video. Try the rest of the table yourself, the entire thing. Come back and I'll have the solutions for you in like 5 seconds. So pause the video, use this model here to compute some more values on your own, then come back. Welcome back. So here you can see the rest of the values. Check your work for all of them. And I have down below also my work for what you get when you substitute 8 in place of x. So check your work. Make sure you can do all this without a calculator. This is no calculator for this part of the test. So yes, you should be able to square every number up to 11 and have those all memorized. 10 times anything is fair game. Adding integers is all fair game. So make sure that you can do the number math correctly and accurately without a calculator. Now, one point to make behind this table is you only have to do half the work once you find the vertex. And we'll see that later on, but check this out. The highest the points ever go is 25. This middle point will be the vertex. Then look on either side. Think about the shape of parabolas. An upside down parabola, which is what you get when you throw stuff, looks like this, right? Well, that means every time you throw something up, what goes up must come down on the other side at the same height. So what you have in this table is you have a vertex in the middle. That's right here, this guy, 525. Then on either side, there's balanced points. So we have 24 on the left-hand side when it's going up, and 24 on the right-hand side when it's going down. So technically, once you did this part of the table from here to here, you could have said, oh, wow, look, 24 and 24, I know this has to be 21 because it has to match the other side, because parabolas have equal points on either side of the line of symmetry. So consider that next time that you do a parabola. Next up, let's go ahead and plot our points. And I'm going to start with the vertex because that's going to be the center of our parabola. The vertex is right here at 525. So we're going to go over 5 units in the x direction and then up 25. In fact, before I do that, let's scale our axes. So press pause and go ahead and scale your axes. That's what I'm going to do. I'm going to pause, scale it, and come back in a second. All right, now that I have my x-axis and y-axis scaled, notice I have labels 5, 10, 15, 20. I chose ones. I have my x-axis labeled as x, my y-axis is labeled as y, and now plotting the points is much easier because to plot 525, I can easily see when I go over 5 that it's right here. Then up 25, I can easily go up from there to 25 without having to count all over again because I have 25 labeled. So there's the vertex at 525, plot it, cool. And then go ahead and I'll do one more. Let's do 424. So over 4 on the x-axis will be 1 before 5, but 24 is the height, so it's 1 less than 25. And there's 4 over in the x direction and 24 up in the y direction. So go ahead and press pause and plot the other points on your own if you haven't done so yet. All right, here I've got my parabola graphed, and it's looking good. Note that it's balanced. If I wanted to draw the line of symmetry right down the middle, I can do that right here. Here's the line of symmetry. And on each side, the parabola has balanced points. It's always true in the case of a parabola. So it's helpful because you would know if something's off or not just by looking to see if your points are balanced. So that's one check. So I'll scroll through my parabola here and you can check your answers. So there's the top of the parabola. I've just plotted the points. Then down below, here's the rest of the points. Now whether or not you plotted below the axis here is debatable. We'll discuss that when we get to part F. But there you go, just check your work. Next up is the factored form, and on the actual quiz or practice test, I know I had an X here in a rectangle. I apologize, it kind of leads you in the wrong direction perhaps. You can factor this with diamonds or rectangles, but look at this thing. There's always a step you need to do before you start diamonds or rectangles, and that is you need to look for a common factor before diamonds every single time. In this case, there's a common factor of X in both terms. So even before you would try diamond, you should still factor a common term. In this case, that's going to lead you to, again, pause the video and factor out that common factor yourself. Go for it. Welcome back. Now you notice that X is a common factor. Factor it out, and left over is, let me undo that, just negative X and then plus 10. And you can always check your work by going backwards. In our case, let's try this out. If this is right, if when we multiply it back, what's x times negative x? Negative x squared, that part checks out. Distribute x times 10 is 10x. So since our answer multiplies back to the original, we're sure that it's correctly factored. Now, the next step would be to see if what's left inside is still factorable. But look, there's no x squareds, there's no other common factors besides 1, so this is the factored form. And done. There's the factored form. So this concludes part 1 of question 1. And in the second video, we'll go ahead and discuss parts A through F, which really it's much quicker, much easier to do now that we have the hard work of the graph done. So I'll see you next video.